All right, let's take a look at some of the homework problems for tonight. So we have to solve the following inequalities and then write the final solution in interval notation. All right, number one. So we're still going to follow the same process that we've been using in class, the DCMS, distribute, combine, move, and then solve. That's the typical order for solving equations or inequalities. Sometimes it's better to not use this process. We can kind of like change the order sometimes, but in general, DCMS is how we handle most things. All right, so the first one, just drop down the left side, and then in the right, we're going to distribute the 7. Again, we only distribute that 7 to whatever's in parentheses, okay? So 7 times 8 would give us 56, and then 7 times negative 2x is negative 14x, and then the plus 12, we will drop it down. So that's the distribution step, okay? Now we're going to combine like terms. So on the left side, there's nothing, but on the right side, I see 56 and 12, okay? Combine those first before you go to the move step. All right, I see a lot of students trying to like subtract 56 or subtract 12. Combine like terms first before you start moving across that inequality. All right, so 56 and 12 would give us 68, and then we'll drop everything else down. All right, so I'm going to add 14x. We need to get all of the x's on one side. So let's do that. So we'll drop down 2. Negative 3 plus 14x becomes positive 11x. Drop down the symbol. 68, and then this cancels to 0. Okay, so we're getting there. 2 more steps. Let's subtract 2 from both sides. So we get 11x is greater than or equal to 66. Divide both sides by 11. So x is greater than or equal to positive 6. Okay, so that's the first part. The second part is presenting this in interval notation. So we would start at 6. We're going to use a bracket because it's included, because we see the little equal to symbol underneath, and that's going to shoot out to infinity. Okay, so that's our solution set. So there's your inequality, and there's your interval notation. Okay, all right, number 2 is slightly different because we have a fraction. This is where DCMS gets a little bit violated here. So I'm going to move over the x first. This is one way to approach the problem. And then we'll deal with the fraction in the next step. So now I'm going to multiply the left side by 3 to cancel out this fraction. And what I do to one side, I'm going to have to do to the other. So I have to distribute that 3 to both terms on the right side. So we'll get 4 minus 2x is less than 3x minus 12. And then from here, it should be pretty straightforward. I'm going to move these x's over. So I'm going to get 4 minus 5x is less than, that'll cancel to 0, negative 12. 2 more steps. So we'll do minus 4 on both sides. Negative 5x is less than negative 16. And then we'll divide by negative 5. Now, because I'm dividing by negative 5, right, I'm dividing by a negative. We have to flip the symbol, okay? That's super important. So now, my final answer is going to be x is greater than 16 over 5. Okay, that's the inequality solution. And then interval notation would be 16 over 5 to infinity with 2 parentheses on either end. Okay, so it's all the values that are bigger than 16 over 5, not including it. Okay. All right, number 3. Number 3 is not hard, but there's some fraction work. All right, so we got to remember, I'm going to do a little bit of fraction work over here. If you're multiplying fractions, you can go straight across, or you can cross simplify. If you're adding or subtracting fractions, we got to remember that there's supposed to be common denominators. Right, so we're going to have both of those cases here. The first part's not too bad, so it's just 3 over 2x. And then over here in red, I'll do 3 over 2 times 6. A lot of students like to put the 6 over 1. And then I'm going to cross simplify, okay? So we know that anywhere we see 6 over 2, you can just replace that with 3 over 1, right? So since I see this, 6 over 2, I'm going to replace that with a 3 and replace that over 1, all right? So your fractions will work vertically, like top and bottom, or they'll work across your fractions, only when you're multiplying, all right? So now if we go straight across, 3 times 3 would give us 9, and then 1 times 1 would give us just 1. So 3/2 times negative 6 becomes negative 9. And then we'll distribute on this side. There's no fractions here, so we'll get 2x plus 8 minus 5. And then I'm going to combine like terms, so we'll do the left side, we'll drop them down, and then we have 2x, positive 8, and negative 5 would go to plus 3. All right, so now we're going to have to add up some fractions, okay? So I'm going to minus 2x on both sides, okay? Nothing difficult, so we're going to do 3 over 2 minus 2 over 1. Right, it's just 3 over 2 minus 2. But right now they don't have common denominators. So I'm going to multiply this guy by 2 over 2. Okay, so I'm going to rewrite that as 3 over 2. That one I didn't have to change at all. And then instead of writing it as 2 over 1, I can write 4 over 2, which is the same thing. All right, so 4 over 2 just simplifies to 2. So now that these have common denominators, now I can just subtract like normal. So we'll keep the common denominator as 2, and then at the top, 3 minus 4 would give us negative 1. All right, so when I combine these up, I just end up with negative 1/2 x. So negative 1/2 x minus 9, that'll cancel to 0, and we'll drop down the 3. And then, of course, everything should be pretty normal now. So we get negative 1/2 x is greater than 12. Now, in order to cancel this negative 1/2, I'm going to multiply by the reciprocal, which is just negative 2 on both sides. So a couple things there. This 2 and this 2 will cancel, and then the negative and negative will cancel to a positive 1x. That's the point, right? You want to always end up with x by itself. Because we multiplied by a negative, we're going to flip the symbol, and then we have negative 24. Okay, so all the values less than negative 24. So from negative infinity to negative 24 with 2 parentheses. Okay? Not difficult, so you just got to watch and make sure that you're multiplying straight across in your fractions. Take advantage of cross-simplifying, and then when you're adding, make sure that you have common denominators. All right, so this one, number 4, I'm going to work from the inside out. So I'm going to do 6, and I'm going to handle whatever's on the inside of these brackets here. So let me distribute that negative, so we get negative 3x plus 1, and then I'll close off the brackets. Greater than or equal to, let's distribute that 4 through, so we get 12x minus 28. And I'm still going to focus here. I'm still going to focus on the brackets, and then once that's simplified, then I'll go back for that 6. So 6, still in brackets. I've got some like terms to combine. 5x minus 3x would give us 2x. Drop down plus 1. That looks pretty good. The other side will drop them down. And now I'll deal with the 6. Okay, so we're going to have 12x plus 6 greater than or equal to 12x minus 28. Okay, so something should be jumping out at you on this one. We notice that we have 12x on both sides. Okay, so that means they're going to cancel, right? If I subtracted out 12x on both sides, those would go away. So now what I want to check is this answer going to be true or not? So is this mathematically true? Is 6 greater than or equal to negative 28? Yes. Okay, that's always going to be true, which means that any answer that you plug in, any number, any value, any real number is going to work and make this mathematically true. So this is all real numbers for this here. If I ended up with something that wasn't true, then it would be no solution. Okay, but since this is always true, 6 is greater than or equal to negative 28, we know that it's all real numbers. Okay, those are the basic inequalities. Now we have some compounds, so I'm going to basically solve these out independently of each other, and then we'll kind of check to see what our answers are going to be. Let's see. So let me add 1 to both sides. So this is negative 27. Divide by 3. So x is greater than. I'm not going to flip here. Okay, so a lot of students get this mixed up. I divided by a positive 3. So positive 3, no flipping. Okay, only when you divide by or multiply by a negative. Just because this negative 27 is in the numerator has nothing to do with what you divided by. Okay, we're dividing by a positive 3, so no flipping. And then what's that, negative 9? All right, so that's the first piece, right? And then the other piece is, let's subtract 7 both sides. So we get 2x is less than, what's that? 19 minus 7, what's that, 12? So then x is less than 6. Okay, so I need a case. I'm just going to graph this. So I have some value happening at negative 9 and at positive 6. So I want the numbers, I'm going to graph 3 of them. So if I graph just this one, I'll do this one in blue. So this would be strictly greater than -9. I'll do this one in purple. This one's going to be strictly less than 6, and then I want to graph where they overlap. Okay, I want the numbers where both of these inequalities are satisfied. Okay, and that's going to happen from -9, not including it, to +6, not including it. All right, so it's just the overlap. So if I was to graph the final answer, it would be a line segment, open, open, and then connect them. So any number in between this little line segment would make both of those inequalities true. All right, so that's kind of what we're looking for. Okay, so this one is an OR. Algebraically, it'll work similarly. So we'll add 2 to both sides. So we get 4x is greater than 16. Divide both sides by 4. So we'll get x is greater than 4. Similar idea on this one. So we get 3x is less than or equal to -9. Divided by 3, no flipping because the 3 is positive. So we have either this or this. Okay, so on a number line, we have something happening at -3. We'll call that 0. Here's 4. So the values can be either greater than 4 or less than or equal to -3. Okay, so this is when we have to have the u in interval notation. Notice there's a huge gap of values that would not work. Okay, those values would not make either of those inequalities true. So we're going to take those out of the solution set. So anything from -infinity up to -3, including it, united with anything from 4, not including it, to infinity. All right, that's going to be our solution set. So it's helpful to graph them if you need to come up with interval notation. Should be an arrow there. And that's your final answer in interval notation.